Hi everyone, today we're going to talk about linear inequalities, how to graph linear inequalities in two variables. And this is section 4.4. So this is going to look a little different. Before we had stuff like this, y is greater than 5, and you would use a number line, right? And you would have a 5, 6, 4, and you would say x is greater than 5. And it would be an open circle, and you would go to the right because these numbers are numbers that are larger than 5. So today we're going to talk about more like a linear equation. So you see we have x and y in these problems. So they do look a little different. All right, so I wrote down some steps here we're going to, go back and forth with. But the first thing we're going to do is graph this line. So notice this is really nice because this is in slope-intercept form, like y equals mx plus b. Now I know this isn't an equal sign, but our first step is we're going to graph the line just like as if it is equation, just like that's an equal sign, okay? So when I look here, y equals mx plus b, I see the y-intercept is -1, so I'm going to go to -1. And then the slope is the coefficient of x, which is 1. So that means I have to go up 1 over 1, up 1 over 1. And I know some of you guys like to leave all these little dots. That drives me crazy. So now it's going to get a tiny bit different. Okay, I kind of wrote this at the bottom here. So if you see a greater than or less than or equal to sign, it's going to be a solid line, which means we're going to connect the points. If you don't see that line underneath it, it's going to be a dotted line. And usually it actually looks like a dashed line like that, okay? However, let's go back here and look. This is less than or equal to, so I'm going to make it a solid line. Okay, so what have we done? We have an equation, an inequality. It's in slope-intercept form, so I'm going to graph it. I have to reflect back here and see if it's going to be a solid line or a dotted line, okay? Now, the next step is I'm going to test a point. And so I have to figure out where my answers are. Are my answers going to be on this side of the line, or are they going to be on this side of the line? So what I do is I test a point that's not on the line. So I like to test the origin, but if this line was going through the origin, I wouldn't be able to test it. Now, technically, you can test any point that's not on the line. So I could plug in 0, 0, I could plug in 1, 1, because that's not on the line. I could plug in -4, 3, but why make our lives difficult? So I'm going to plug in the origin, which is right here, okay? If it's true, if the statement I get is true, then I'm going to shade in wherever that test point was, because it means that test point worked. If it's not true, then it means the other side works. So let's see. We're going to plug in the origin, okay? 0 is less than or equal to 0 minus 1. 0 is less than or equal to -1. Is 0 less than -1? No, 0 is greater than -1. So we tested this point, and that is not true. Therefore, we have to shade this side. And what that means is every single point on this side should work. So usually you would end the problem there and you would just move on. But I just want to show you this example. So if I plug in, let's try 1, 2, 3, 3, 1. It should work. 3, 1 should work. Okay, so if I plug a 1 for my y, 3 here, and then I would say 1 is less than or equal to 2. 1 is less than 2, so it worked. All right. So occasionally, you might get a multiple choice question that it has this equation and it gives you like 5 or 6 points. It says like 3, 2, -5, 1, 6, 9, 2, -3. And you have to pick which of these coordinates works for that inequality. Well, if they give you the inequality, you could plug it in, or if you looked here, then you could look and see if it worked too. 3, 2, 1, 2, 3, 1, 2. Well, that's right on the line. Since it's a solid line, that would work. -5, 1, well, that's not going to work. 6, 1, 2, 3, 4, 5, 6, well, that's not going to work. 2, -3, that is going to work. So you would say those coordinates worked. Those coordinates were solutions to this inequality. Okay, so real quick, let's recap. We looked at the equation, we graphed the line, we decided if it was dotted or solid. We then tested a point and we shaded accordingly. That's it. This was just a little side note. Okay, so let's look at this one right here. What are the solutions to y is greater than x plus 3? Well, you guys go ahead and graph that and then check it. You can pause the camera if you want. The y-intercept is 3. The slope is 1. Rise 1, run 1, rise 1, run 1. Okay, now there is no line underneath it, so it's going to be a dashed line. Usually it looks like this. I know it says dotted. Okay, and now we have to test a point. Well, since this line is not going through the origin, I'm going to test the origin. 0 is greater than 0 plus 3. 0 is greater than 3. All right, is 0 greater than 3? No, it's not. That means this point does not work. That means all of these points work. So your answer to these is a picture. Your answer is this picture. Your answer is not any of this math. You just needed this math to see if the test point worked or not. But your answer should be a picture because it's every single one of these coordinates over here. All right, let's look at this problem. And what do we notice? Oh, this is not in slope-intercept form. It was so nice when it was. So you can either convert this so that it is in slope-intercept form, or we can plug in and find the x and the y's. Most of my students have been into turning it into slope-intercept form, so I'm going to do that method. So I would subtract my 10x from both sides. Okay. Divide by 2. This is going to be kind of a nightmare to graph. All right, so now I have my y-intercept of 25. Let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. What if I went by 5s? Oh yeah, we could do that. We could go by 5s. 5, 10, 15, 20, 25. So if I'm going by ones, I don't have to write any numbers, but if I'm going by something different, I do need to. So 5, 10, 15, 20, 25, 30, 35, and then I'm just going to do these as by 5s as well. Actually, I don't have to. I can do these by 1s. Okay, so let's start graphing. My y-intercept is -25. I'm sorry, positive 25, and my slope is -5. And I kind of wanted to go by different increments, just really to refresh your memory on something. I'm going to make this a fraction, -5/1. So I go down 5. Notice this is 5, and I'm going to go over 1. So this is a -5 slope. It's going down 5, and it's only going over 1 unit because I went these over by 1. Okay. Down 5 over 1, down 5 over 1, down 5 over 1. Now, this should be a solid line. And I'm going to test the origin since the line is not going through the origin. I like to go back to my original. It doesn't really matter though. Okay, 10 times 0 is 0, plus 2 times 0 is 0. And that is greater than or equal to 50. 0 is greater than 50. No. So it means that all of these work. And remember, if you don't feel 100% confident, you're like, wait a second, I'm not positive. I can try plugging it down here too. 0 is greater than 25. 0 is not greater than 25, so it didn't work. Or I can try to plug in a number that would work and see, then I should get a true statement. Okay? All right, just one more or two more. Okay, what I wanted to do here and now I've given you the picture, I've given you the answer, and I'm asking you for the inequality. So what inequality would work? Well, I prefer to write things in slope-intercept form, so I'm going to go ahead in my mind, I'm thinking y equals mx plus b. All right, so right now I look at the y-intercept. It might be difficult for you guys to see because this copy is super light. My y-intercept here is -3. Okay, so I'm going to put a -3 in the y-intercept spot. The slope is 1. I'm sorry, I keep having a slope of 1 today. Okay, now, so I have y. I know this is not going to be an equal sign because I do have shading in. I have to figure out, well, I know it's a dotted line, so it's either going to look like less than or greater than. We're not going to have the line underneath, and we have to figure out which one it is. Okay, so we know that this point needs to be false. We know that the origin needs to be false. So if I plugged in the origin, 0, 0, -3, 0, -3. Well, 0 is greater than, 0 is greater than -3, but I need this to be wrong. So I'm going to say 0 is less than -3. So this is my inequality. And I'm going to double check that because I don't feel great about that answer. So when I plug in my origin, 0, 0, 0 is less than -3. That is incorrect. And if I wanted to try something that was correct, I might say 1, 2, 3, 4, 5. Let's use 5, 1. 5, 1. So 1 is my y. 1 is less than 2, and I tried a number that would work, a number that was in my shaded region. 5, 1 was right here, and it does work, so that is correct. So this is my inequality. All right. Now, I did want to touch base with you about, remember, sometimes if it's just a line going straight across. Now, you know, I always like Slope Guide. Refresh your memory on this. So actually, Slope Guide doesn't really help with this. It says that the slope of a line straight across is 0 and the slope of a line this way is undefined. So let's look at this. I remember, and I always get confused, I always mix up. I know that if the line is going this way or this way, it's not angled, that it's either going to say X or Y. And I forget all the time which it is. So I'm looking here going, okay, this was what most of my students will say. This line is going through the Y, so it's going to say Y. Just for right now, I'm going to put an equal sign, Y equals 2. Now, Miss Knight always gets this wrong, and I feel like I always forget this. So this is kind of how I double check myself. I say to myself, well, that means that the coordinates, all the Y values have to be 2. All right, so 1, 2, I'm making up whatever I want here. All right, let's see if these coordinates are on this line. 1, 2, yep. -2, 2, yep. Okay, so it was Y equals 2. So the equation for this line is Y equals 2. All right, and we now need to fill in the inequality. Well, it's a solid line, so we know it's going to be either less than or greater than and equal to. We have to figure out which way we're shading. Okay, so the origin right here is 0, 0, and the origin is true, so we want the origin to work. Okay, so I'm going to plug it in. 0, 2. 0 is less than 2, and I want it to work. So my inequality would say Y is less than 2. Okay? Thank you guys, and we're going to practice this more. See you later. Bye.